Hello everyone. Good evening. Good evening everyone. Quickly tell me, am I audible? Quickly tell me guys, am I audible or not? Yeah, so I'm audible. Great. So first of all, good evening guys. Myself Lakshay Sachdeva and I am your mentor for this 3-day bootcamp that is based on AI recommendation system in which we are going to make an AI movie recommendation API. Okay. So very good evening. So we will be starting this session, the day 2 in 2 to 3 more minutes, okay, so that everyone can join. Till then, if any one of you have any kind of doubts, you can ask me in the chat. We will be starting this session in within 2 to 3 more minutes, okay. Till then, if any one of you have any kind of doubt, you can ask me in the chat regarding the day 1 or anything regarding, okay. Where can we get dataset? So I have already shared the dataset with you guys, if I'm not wrong. So you guys can get the data set, all the notes, your all the coding files, everything in with the help of your group community link. Okay, in the community description. You can find everything in the community description. Yes, surely we will start the session with a quick revision. So don't worry. Yes, with the help of this project, you will get to know two very main concepts of machine learning, that are the similarity search and vectorization. Like how can we perform the vectorization, and based on that vectorization, how can we perform the similarity search. So these are very important concepts actually in this field, that is machine learning. Yes. So yes, this it is necessary to submit the mini project. Okay, for the certificate, it is necessary to submit the mini project, and all the details regarding the project will be shared to you guys with the within the community only. And by chance, if you have missed any of the lectures, so don't worry, just attend the rest of the 2 lectures. That is today's session and tomorrow's session. So 1 more minute may be okay, and then we can start with the session. Any more doubt, guys? You can ask me in the chat. The dataset is there in the community description, so you guys can access all the dataset, notes, and everything by joining the community only. Yes, everything, all the files, everything is there in the description of the community. Okay. the WhatsApp community. Okay, so let's quickly begin with today's session. So I will start with a quick recap first of all. Okay, so let me just share my screen. Yes. So I hope my screen is visible, guys. Okay, so let's quickly start with today's session. First of all, let's quickly have a recap of day one. Okay, so what we did in day one, we had a okay. Just give me a second. Yes. So in day one, first of all, we have discussed that we are going to discuss two very important concepts in with the help of this bootcamp, that are vectorization and similarity search. Okay, okay, sir. So one of the topic, that is vectorization, we have already covered. So what is vectorization? Vectorization, we can say that when we have categorical data or data in the form of sentences or words or something, so we convert those words or sentences into vectors so that we can send the data, or we can train the models based on that data. Okay, when we have data in the categorical form, when we have data in the categorical format in sentences or in keywords or something, so we convert that data into vectors so that we can train the models based on that data. So when we convert that data from categorical form to vectors, we call it vectorization. When we convert categorical data, when we convert categorical data to vectors. Okay, so this is what we call vectorization. I hope this much is clear. Great. Then we have seen the flow of our bootcamp. That is the day one. We did the we explore our dataset first of all. We done the vectorization part with the help of TF-IDF, and then we pre-processed. Actually, we pre-processed not that much, but yes, a little bit of things that like filling the null values and all we did in the pre-processing part. In day two, that is today, we are first revising it, of course. Then we are going to perform the similarity search with the help of cosine similarity. Okay, so I am not going to go deep in this cosine similarity part, like what is the rule of and everything of cosine similarity, how can we find the similarity and everything. I'm not gonna go that much deep in similarity part, but yes, I will give you a proper overview so that you guys will get to know what actually is similarity search. And then we will be building our project. And in day 3, we are finally going to deploy our project. So this is what we did in day 1. First of all, we just saw what is actually machine learning. Okay. So what is machine learning? When the machine is learning from some kind of data to perform independently. Okay. So machine learns with the help of some kind of algorithm. Okay. So over here, AB is, I'm referring to some random algorithm. Okay, nothing. It is not like AB is some algorithm. I'm referring to any random algorithm over here. Okay, then this is nothing. Then we have discussed about the TF-IDF, that is term frequency inverse document frequency. So what is term frequency and inverse document frequencies? These are some formulas for term frequency and inverse document frequency. Based on these formulas, we get some kind of vectors. Okay, based on these formulas, we get some kind of vectors through which we can convert our data. I hope a basic things are clear. Okay, so let's quickly move on with the day 2. So first of all, In day 2 we are going to cover similarity search. Okay. So first of all, tell me guys, is there any doubt regarding day 1 of the bootcamp? Quickly tell me guys, is there any doubt regarding day 1 of this bootcamp? Or else if everything is clear, then write clear in the chat. Okay. If everything is clear till now, write clear in the chat. Quickly guys. Okay, I think so. Many things are clear now. Great. So let's move on. So my question is, what is similarity search? Okay. So let's say I have a vector of, so I'm taking random values. Okay. So I have something a value like 25. Okay. Now I have another value, let's say 20, and I have another value, let's say 55. Okay. So these are the two values, 20 and 55. So can you guys tell me which one is the closest value to 25? Can you tell me which one is the closest value to 25? So as you guys predicted, 20 is the closest value to 25. 55 is also close to 25. But if you compare the difference, so after comparing the difference over here, the difference is 5. Okay. After comparing the difference is 5 over here. And if similarly we compare the difference over here, the difference is 30. So as you can see, the difference over here is very less than the difference in case 2. This is my case 2. This one is my case 2. This one is my case 1. So the difference is very less in case 1 as compared to case 2. So can I say that case 1, can I say that case 1 is little more similar, is a little more similar than case 2? Okay, let's say this is my root. This 25 value is my root. Okay, so can I say that case 1 is little more similar, is little more similar to root than compared to case 2? So can I say this conclusion that 20 is much more closer, or 20 is more similar to 55? Okay, so I can say that case 1 is little more similar to the root, that is case 2 as compared to case 2. Okay, sir. So this is exactly how the similarity search also works. So let's say if I give you example, let's say I have a movie Iron Man. Okay, I have a movie Iron Man, and I got a vector like 0.5. I got a vector 0.5 for the movie Iron Man. So what my model is going to do? What my model is going to do? My model will find the similarity. Let's say all the movies I have is Iron Man 2, Iron Man 3, let's say Superman. So I'm writing the short forms. Okay, Superman, Spider-Man, and let's say Batman. So these are the 5 movies. Let's say these are the 5 movies in my data set. Okay, so I want to find the movie that is much more similar to Iron Man. Okay, I want to find a movie that is much more similar to Iron Man. And I have five movies over here, that is Iron Man 2, Iron Man 3, Superman, Spider Man, and Batman. So, what I'm going to do, I am going to convert these movies into vectors as well. Okay, I am going to convert these movies into vectors as well. Let's say the vectors of these movies are, let's say the vectors of these movies are 0.45, 0.40. Okay, let's say the vector for Superman is 0.3, for Spider-Man is 0.7, and for Batman is, let's say 0.8. Okay, so these are the vectors for all of these movies. So how can I know that which movie should I watch next? How can I know that which movie should I watch next if I have watched Iron Man? So I will calculate the difference. I will calculate the difference between the vector value of my current movie and the vector value of my other movies. Okay, I will calculate the difference between the vector value of my current movie, that is the zero point 0.5 over here, and the values and the vector values of all other movies, so that I can get the similarity search over here, so that I can get the similarity score over here. Okay, so let's say the similarity score is 0.5 minus 0.45, that is 0.05. In this case, it is 0.1. Then in this case, it is 0.2, again 0.2, and in this case, it is 0.3. So wherever the similarity score is minimum, wherever the similarity score is minimum, wherever the similarity score is minimum, can I say that? Can I say that this movie is much more similar to the original movie because the similarity score is minimum? Like there is not much difference between these two movies. Can I say that? So can I say that Iron Man is very much similar to Iron Man 2, and after that comes the Iron Man 3, and then the Superman, Spider-Man are equal, and then the Batman. So will this be my order of watching? I will get this order of watching, right? So my recommendation will suggest me Iron Man 2, then it will suggest me Iron Man 3, then it will suggest me Superman and Spider-Man, let's say, and after that Batman. So this will be the order in which my movie recommendation system is going to suggest me all the movies. I hope this much is clear. I hope this much is clear, guys. Quickly tell me, guys, is everything till now clear or not? Vector values based on, like when we are converting categorical value into numerical format, so we are actually converting them into vectors, right? So similar values, similar categories will get similar kind of vectors. Okay, so let's say if I have a word iron. Okay, let's say I have a movie Iron Man. Okay, and I am getting a vector 0.4 for Iron Man. Then for Iron Man 2 as well, the vector will not change much. I will get a similar vector like Iron Man 4 3. Okay, so I'm taking random values right now, but just to show you that if the word is Iron Man and I am getting the vector 0.4, so for the case of Iron Man 2 as well, I will get a very similar kind of vector. Again, if I will take Iron Man 3, I will get again a similar kind of vector, let's say 0.44 or 0.45. These are all random values right now, just to show you how vectorization works. How do we get the values? How can we calculate the similarity score? Is this clear now? Quickly tell me, guys, in the chat. If everything till now is clear, right? Clear. Quickly, guys. The attendance link will be shared at the end of the session, so please wait. If you have any kind of doubt, you can ask me in the chat. Great. I hope the things are now much more clear. Great. So, what should we do now? Let's quickly move on to the practical implementation. Okay. Let's quickly move on to the practical part. So, give me a second. Okay. So, I hope this was the notebook that we were working on. And yes. So, we were working on this notebook, right? So, two things before starting that I'm going to do. Yes, everything over here is based on characters and words and everything. Okay. How are we converting characters into vectors? And then how are we comparing those vectors and how are we finding the similarities and everything? So everything is compared to is related to that. So now this was the project that we were working on. Two things that I'm going to do. I first of all I'm going to connect my notebook. Okay. If you can see in the top right corner over here, I have an option connect. So I'm going to connect my notebook. So it will take a minute and it will quickly connect. Yes, I'm going to revise this code once more. So as you can see, it is connected now. The second thing, I'm going to upload the dataset again over here. So this was the dataset. And let me just check it. Where's the dataset gone? I will upload it quickly again. Okay, why is it not showing? Let me do one thing. Let me just quickly reload the site. Okay. Yes. So now what I will do, first of all, it is connecting. It is connected successfully. Then I will just quickly, yes, upload the dataset over here. And now if you can see, the dataset is uploading. The dataset is already shared in the group community. Okay. But if you are unable to find the dataset, you can just simply go to Kaggle and you can select your own dataset as well. Okay. You can select your own dataset as well. Let me just quickly sign in. You can go to datasets over here and you can check for any kind of movies dataset or something. So there is this movie dataset over here, and Yeah, as you can see, it consists of the cast and crew and ID something. So you can find many data sets over here, and you can select a data set from here as well. It will not be a problem. So it's another IMDb movie data set. Yes, you can also take this data set if you want. So you can select the particular columns only, like series title and genre, then overview. You can and director name. You can also take this data set and like just take all these four important columns and work on this as well. So anything is possible. Okay, it is not like you have to work on this particular data set only. I have provided this data set as well, but it is not compulsory that you have to work on this only. You can go to Kaggle and you can select any data set of your choice. I hope this much is clear. Okay, let's quickly start with it now. So as you can see, my notebook is successfully connected as I'm getting all the output. Then I have imported some of the libraries. First of all, I have imported NumPy as NP and Pandas as PD. Okay. So whenever I want to play with numbers, okay, in Python, whenever I want to play with numbers in Python, I use the library NumPy. And whenever I want to create data frames and data sets and everything, whenever I have to handle the data sets, I'm going to use the library Pandas. Now, sir, what is this difflib and this TF-IDF vectorizer and cosine similarity? So let me explain. So in today's lecture, we are going to work with difflib and cosine similarity. So this I'm going to explain further on. First of all, this TF-IDF vectorizer. So in last session as well, we have learned about vectorization, that we are converting characters or sentences or categorical columns into vectors with the help of TF-IDF vectorizer. It is not like it is one and only technique to convert these things. There are many more techniques like one hot encoding and on label encoding and many more techniques. But right now, I am going to show with the help of TF-IDF vectorizer. What's the difference between data mining and so data mining also comes under data science, but it is like when you have to extract lots and bulks of data and you have to pre-process and clear up the data. So I'm not going in detail right now. So this is a basic difference. Okay, then I have taken the data set over here, that is movies underscore data, and I have used it using PD. What is PD? It is pandas, because pandas provide me a function that is dot read underscore csv. So with the help of this, I have taken this data set over here. So if I will print the data set, you guys can see the data set over here. What is sklearn? So scikit-learn, sklearn stands for scikit-learn over here. So scikit-learn is a very famous library. Like there are 2 3 libraries like scikit-learn, TensorFlow, PyTorch. These are very important libraries for machine learning and deep learning part. Okay. So scikit-learn is majorly used in machine learning portion, and TensorFlow and PyTorch are majorly used in deep learning portion. Then we can see the shape of our movies data as well. That is 40803 comma 24, which means that we have 4800 rows, means that we have 4800 rows and 24 columns. Then this is my selected features. So what actually is my selected features is, these are the features I am going to combine and I am going to make the vectors. Okay, these are the features that I'm going to combine and make the vectors. So as you can see, first of all, I have removed any null values in these features. First of all, I have removed any null value present in this features with the help of a function known as dot fill na. Okay, with the help of a function known as dot fill na. So it helps us to remove all the null values in any of the column listed over here. I hope this much is clear. Okay. And then we have simply combined all of these features. Okay. So as you can see, we have combined all of these features in one column only. Then we have initialized our vectorizer, that is TF-IDF vectorizer, and I have implemented my vectorizer with a function called dot fit underscore transform. So when I have printed all the feature vectors, you can see these are all the values. These are all the values that I got. All the vectors, we can say. So I hope this much is clear, guys. These are all the vectors that I got after performing vectorization. So this was the code that we did in last lecture. If everything till now is clear, please write clear in the chat quickly, guys. Sir, explain 15th line. So where is the 15th line actually? I hope. Wow, there is no 15th line. I hope everything till now is clear. The attendance link will be shared soon, so please, guys, focus on the uh, learning part right now. So let's move on with today's session. Okay, like today's code. Great. So first of all, I have to initialize my similarity. Okay, so I'm going to write similarity is equal to cosine underscore similarity, and within this cosine similarity I'm going to give my feature vectors. So what is my feature vectors? These all are my feature vectors. Okay, so these all are my feature vectors. So what I'm going to do, I am going to give these feature vectors to my cosine similarity function, and I will run this cell. Now if I will print the similarity, now if I will print the similarity over here, so you guys can see the similarity somewhat. Okay, so what is it printing? What is it printing now? So if you can see, there are like I'll just show you one thing. Print. Okay, let's not go print. Let's say similarity dot shape. As you can see, this shape of the similarity is 4803 cross 4803. So what are we getting over here? We are getting, let's say, this is my data set. Okay, so we are getting a similarity of a particular movie with each and every movies. Okay, so let's say these are all the movies like Iron Man, Iron Man 2, Iron Man 3, Batman, Superman, and all and all. Okay, so these are all the movies. So I am taking each and every movie one by one, and I'm calculating the similarity of each movie with all the others. Okay, so let's say Iron Man match. So I will get the similarity 1. Then let's say if I will take Iron Man 2, so we will have some kind of similarity over here. Then in this case, again Iron Man 2 match, I will have the similarity as 1. 1 means over here 100%. Okay. And again moving forward we will have many more similarities. So as you can see, this is what we are exactly doing. We are checking the similarity for each movie with respect to all the other movies that we have in our data set. So that is why I am getting a matrix of shade 4803 cross 4803, because 4803 is nothing but the total number of rows in my data set, and this one over here denotes that we are getting a 100% match. And as you can see, all the diagonal elements are 1 over here. I hope this much is pretty much clear to you guys. I hope this thing is pretty much clear to you guys. Yes, this is a square matrix. Okay, I hope this much is clear. Then again, next step. So what I am going to do now? So I am going to take the titles of all the movies. Okay, I am going to take the title of all the movies. Let's say I'm taking list of all titles. Okay, I'm going to take a list of all the titles. So I am going to write movies underscore data, uh, title. I will get the title. Yes, I will get the title from movies underscore data, and I will create a list, to underscore list. So now if I will print list of all titles, you can see that I got a list of each and every title. Okay, I got a list of each and every title. Now, sir, why have we taken the list of all the titles? Sir, why have we taken the list of all the titles? Let's say, let's say, let's say, let's say I am taking some input from the user that, hey, user, what kind of movie have you seen so that I can recommend you more movies? And let's say the user gave the output as input as iron MNA. Okay. So if the user gave the input as iron MNA, but the actual movie is Iron Man, right? The actual movie is Iron Man. But let's say the user give iron MNA, because there can be any typing mistake, right? Anyone can do the typing mistake. So what I'm trying to do, if there is some kind of typing mistake or something, so I'm automatically going to convert this typing mistake to the closest movie that is there in the list of mine. Okay, what I'm going to do, I'm going to convert this typing mistake or the given user input into the closest movie that I have in my list. Okay, closest matching movie. So that is why I have taken the list of all the titles over here. That is why I have taken the list of all the titles over here. So what is my next step? I will find the closest match. So I will write find close match. Okay, I will write find close match equal to. Now here comes the part of difflib library. Okay, so if you guys remember, I have imported a library called difflib. Okay, I have imported a library called difflib. So we are going to use difflib over here. So I'm going to write difflib dot get close matches, difflib dot get close matches. I'm going to give the movie name. Okay, let me just take a user input as well. Okay, let's say I'm taking movie underscore name is equal to input, enter your favorite movie. Okay, so I'm taking a movie name as input from the user. So if I will run this cell, I will get an input column, and let's say I give Iron Man. Okay, so now what I'm going to take, I'm going to take the movie name over here, and I'm going to take the features list. Okay, I'm going to compare this movie name with the features list. Okay, sorry, the list of all the titles, list of all titles, and I will run this cell. I hope you got this point right. So what I'm going to do, I'm going to take the movie name from the user, and I'm going to get the closest match in my list of all titles. Now if I will print this find close match, so as you can see, I got three matches over here. That is Iron Man, Iron Man 3, Iron Man 2. If I will just check Iron MNA, okay, MNA, the example that I gave in the, okay, this is the example that I gave, right? So if I will take Iron MNA, now if I will run this cell and I will print the closest match, as you can see, it gave me the correct output, that is Iron Man, Iron Man 3, Iron Man 2. So it gave me the closest matches. I hope this is clear. So right now I am taking Iron Man only in the correct form, Iron Man, and I will get the closest match over here. I hope this much is clear, guys. Quickly tell me if everything till now is clear. How can a movie recommendation system truly understand a user's taste without depending only on search history? So what we are going to make over here is, like, the user, if the user is watching some kind of movie, if the user says that, hey, Iron Man is my favorite movie, then based on the similar name, similar genre, similar director, we are going to recommend the movies to the user. Okay, so like if the user loves action movies of this particular director and something, so based on that only, we are recommending the user more and more movies. So I hope this point is a little bit clear to you. So over here we have got the similar, we have the top match over here, so that if the user miswrite something or mistype something, so we can still get the correct movie which user is going to say. Then let's say I'm going to take close underscore match, because I need the first match, right? Only I don't need three matches. So I will write close underscore match is equal to find close. Oh, sorry. I will take find close match of 0, because I want the first closest match only, nothing else. So this will give me Iron Man. Now what I'm going to do, I am going to take the index of the closest match. I am going to find the index of the closest match. Okay. So index of the movie. So I'm going to take the index of the closest match or index of the movie. So I will take movies underscore data. Then I will take movies moving data, movies underscore data dot title. Okay, I'm going to compare the title over here, equal to close match, close match of index. Okay, equal to close match, because the close match is the first value of find close match. Then I'm going to take index over here dot values of 0. So with the help of this, I have got the index of the movie. So as you can see, this Iron Man particular movie, this particular movie Iron Man is at the index 68. So what I have done over here, I have compared the movie's title and the close match. Okay, like if the close match exists in the movie's title, so what I am going to do, I am going to take the index of that particular movie. Okay, I am going to take the index of that particular movie. So as you can see, the index in this case is 68. So now what I am going to do, I am going to check the similarity score of this particular movie with all the other movies existing. Okay, now what I'm going to do, I'm going to check the similarity score of this particular movie with all the other movies. So what I'm going to do, I'm going to take similarity score is equal to list of enumerate. Okay, list of enumerate, and I'm going to take similarity of index of the movie. Now if I will show you the similarity score, so what we are getting over here is, okay, I will just print it instead of showing it complete. Yes. So as you can see, what I am going to do, I am going to find the similarity. I'm going to find the similarity of the index of the movie. Okay. The movie that we are going to search, I will find the similarity of that particular movie with all the other movies. This enumerate over here is combining the index of all the movies and their similarity, and we are making it a list. So as you can see, the similarity of this particular index, that is 68th movie, with the 0th movie is 0.03. Then we have 0.05, then we have 0.013 for with respect to the second movie. So this is how we can get the similarity score with the respect to the particular movie. Okay, this is how we can calculate the similarity score of each and every movie with respect to the particular movie that we have taken. And in our case, we have taken the movie Iron Man. So I think you guys got a little bit like how can we calculate the similarity score. And if I will show you the length of this similarity score, so you can see it is 4803 because total number of movies are 4803, right? So it is giving me the similarity score with respect to all the movies. Now what can I do? Now what can I do? I can sort this. I can sort this based on the similarity score. I can sort this list based on similarity score, right? So I will simply write, okay, sorry. I will simply write sorted underscore similarity underscore, let's say sorted similar movies. Okay, so I'm going to sort this list based on the similarity score. So I will take sorted similar movies as, let's say, equal to sorted. So there is a function sorted in which I am going to give the similar score. I'm going to give the similar score and the key, that is equal to lambda, then we are taking x, that is x of 1. I will quickly explain what is this. Okay, then we are going to take reverse is equal to true. Now what we have done, okay, in the name true is not defined. Okay, sorry, it's with a capital T. So yes, what we have done over here, first of all, we have implemented a function. Okay, we have taken sorted it as a function to sort the list. Okay, then what we have to sort? We have to sort this similarity score. Okay, sir. We have to sort the similarity score. Okay, sir. How to sort the similarity score? So we have to sort this based on this particular value, right? So this particular value comes at the index 1. So we have to sort this similarity score based on this this first particular value, this first value, like this, which is on the first index, right? So we are taking key equal to lambda. Key is the thing like based on which we want to sort our list. Okay, so we want to sort it on x, that is x is the first index, and reverse is equal to true means that we are sorting it in descending order. So if I will print sorted similar movies, I will simply print sorted similar movies. So as you can see, first I got the movie with highest similarity score, that is 100%, that is the 68, that is Iron Man only. Then I got the movie this one with approximately 50%, then this one with 31%, and all and all. Okay. So this is how I have sorted all the movies with respect to their decreasing similarity searches. I hope this much is clear, guys. If everything till now is clear, write clear in the chat quickly, guys. If everything till now is clear, write clear in the chat quickly, guys. Great. Till now, if there's any kind of doubt, you can ask me in the chat. I'm looking the chat right now. If everything is clear, please write clear in the chat and we will move forward. So our last step is to just print the movies, right? Our last step is to print the movies, right? So I will quickly write print movies. I hope everything is clear. Yes. So let's move on. So now my next step is to print all the movies, right? So I will write print movies suggested for you. I will take a backslash n as well. Now I will take I is equal to 1. Now I will add a for loop over here for a movie in sorted similar movies. I will take index is equal to movie of 0. I will take the index as movie of 0. Then I will take title. Okay, sorry. I will take the index as movie of 0. Then I will take the title from index. Okay, I will take the title from index, that is movies underscore data, movies underscore data, and I will take movies underscore data dot index is equal to index. Okay, if I'm verifying if that exists or not. Okay, I'm verifying if the index exists or not. If it exists, then I am going to take the title over here. Title dot values 0. Okay. Then after taking this, I am going to take if I is smaller than 30. So what I'm doing, I am going to take top 30 movies. Okay. I'm going to print I, comma, I'm going to print a dot simply, and I will print the title from, I'm going to simply copy this over here. Okay, and I will paste it, and I will increase it, I plus equal to 1. So let me just quickly run it. Yes, so what I am doing over here, first of all, I am starting with I equal to 1. So now I am taking all the movies and sorted similar movies, right? So I am taking all the movies and sorted similar movies. Now I am taking index as the movie 0. So let's say this is the first thing that in the list that I took. So my index is nothing but 68 right now. So I'm taking index as movie of 0, right? So I'm taking index as 68. Then I'm extracting the title from the index. I'm extracting the title from this particular index. How? First, I am verifying that if the index exists or not, and if the index exists, then I'm going to extract the title. Okay, then I'm going to extract the title and I'm going to save it in title from index, and I am simply checking if I is smaller than 30, then I am simply printing the index over there, and I am increasing the value of I. So as you can see, based on the search, like my search was Iron Man, right? So based on my search, I got all of these related movies, that is Iron Man, Iron Man 2, Iron Man 3, Avengers Age of Ultron, and all and all. So these are all the top 30 movies that I got. 29 movies based on the search that I have done. I hope this much is clear, guys. I hope this much is clear, guys. And to make it more simpler, what I am going to do, I'm going to copy all of these and paste it in a single cell. So first I took the movie name, then I performed the find closest match. After that, I have to take the first closest match. After that, I have to calculate the index of that particular movie. So I will give a space in between. After calculating the index, where was I? Yes. After calculating the index, I am going to calculate the similarity score. After calculating the similarity score, I am going to take the sorted similar movies. and at the end I'm going to print all the movies, right? So let's see if this works or not. So it's asking me to enter my favorite movie. Let's say I gave Iron Man. So as you can see, based on my search, it gave me all the top 29 movies that I can watch. Let's try it again. Let's say this time I am giving it as, let's say I am giving Superman. I don't know if Superman is there in this dataset or not. So yes. So it gave me all the movies, that is Superman, Superman 2, Superman 4, Man of Steel, Superman 3 and all. Let's say if I'm going to give Avengers, so it gave me the suggestions of the Avengers, Age of Ultron, Captain America and all. So this is how it's working perfectly fine. So I hope this much is clear, guys. We are not going to implement any reinforcement learning or any database or time based learning on previous searches and everything, because these things are little complex parts and we cannot cover these things in only 2 to 3 days. So try to understand, we are keeping the things basic but interesting over here. I hope everything is clear, guys. If everything till now is clear, write clear in the chat. If everything till now is clear, write clear in the chat quickly, guys, quickly. So yes, as you can see, we have already made the project, and tomorrow's session we will be like giving it a quick recap, and we will be starting with the deployment part. So yes, this is it for today, guys. All the notes and the codes will be shared to you guys in the WhatsApp community only. And yes, I would suggest to quickly fill out the attendance form because it is very much important for the certificate criteria. So guys, please go and quickly fill out the attendance form for today. And yes, this is it for today. If you have any kind of doubt, you can ask me in the chat. Why we use indexing? So that indexing is just to like, so that we can get the index of that particular movie and we can check the index with all the other movies. Like, it is not a very big deal to use the index. So guys, this is it for today. If you guys have any kind of doubt, you can ask me in the chat. And quickly fill out the attendance form, guys. Yes, I will surely accept the request, don't worry. Yes, you can run this code in any code editor. It will not be a problem. So let's meet tomorrow at the same time, that is 7 o'clock. and we will focus on the deployment part tomorrow. Yes, so this is it for today, guys. If you have filled out the attendance form, you guys can leave. Else, please quickly fill out the attendance form. So, yeah, let's meet tomorrow at 7 o'clock exact, and we will start with the deployment part. Thank you, guys.